Hello everyone. Today we're going to start talking about C++ 11 concurrent programming. Generally speaking, there are two kinds of concurrent programming models. The first one is multiprocessing. For multiprocessing, each process has only one thread running, and all the processes communicate to each other through the regular inter-process communication channels, such as files, pipes, message queues, etc. And the second concurrent programming model is called multi-threading. For multi-threading, one process contains two or more threads, and all the threads communicate to each other through shared memory. So what are the advantage and disadvantage of these two models? First, let's talk about the advantages of the multi-threading. A thread is faster to start. It is usually slow and complicated to start a process because the operating system needs to devote a bunch of internal resources to manage the process. A thread is considered as a lightweight process. And secondly, a thread takes lower overhead in running. A process has more overhead. One example of that is the operating system needs to provide a lot of protection so that one process will not accidentally step onto another process. Another thing is communicating through shared memory is a lot faster than communicating through inter-process communication channels. So in summary, multi-threading provides better performance than multiprocessing. The downside of multi-threading is it is difficult to implement. There are a bunch of threading specific issues that needs to be carefully handled, as you will see in later videos. And another thing is a multi-threading program cannot be run on a distributed system. A multiprocessing program can be easily distributed to multiple computers and run concurrently. For that reason, some people argue that even for multi-threading, the threads should not communicate through shared memory. They should use some kind of channels that is similar to inter-process communication channels. That way, your program can be easily converted to a multiprocessing program and run on a distributed system when it is necessary. But also, the programming becomes much easier. There are a lot less subtle problem needs to be handled. In practice, it is more likely that you will see a mixture of both models. Within the same program, some processes are single-threaded and some processes are multi-threaded. In this class, we'll mainly talk about multi-threading because that's what the C++ standard library provides. Okay, let me start with the simple hello world program. I have a function1, which prints out beauty is only skin deep. And in the main function, I call function1. So if I run this program, it prints out beauty is only skin deep. However, this is not a multi-threading program. There's only one thread running. Now I want to use multi-threading. I create a standard thread T1, and this T1 is constructed with the function1 parameter. So at this point, T1 starts running, and then I call T1.join. What this means is the main thread waits for T1 to finish. So let's run the program again. It still prints out the same message, beauty is only skin deep, but now this message is printed out by the child thread T1. So now we have two threads running, the main thread and a child thread T1. Now suppose T1 is a long-running thread, and my main thread doesn't want to wait for T1 to finish because it has its own business to take care. So instead of calling T1 T1.join, I'm going to call T1.detach. By doing that, I have severed the connection between the main thread and T1. So T1 will run freely on its own, which means T1 becomes a daemon process. And when T1 is finished, because the main thread is no longer connected to the child thread, so the C++ runtime library will be responsible to reclaim the resource of T1. Some daemon process will continue running until the system shut down. Now let's run the program. Now what happened? There's nothing being printed out. It turns out the main thread has run so fast that it actually finished before T1 prints out the message. So T1 didn't get the chance to deliver its message to the standard out. This is very characteristic of concurrent programming. If you have two threads running independently, it is typically not deterministic which thread will run faster, unless you put in some synchronization mechanism, which we'll talk about later. In our particular case, it is actually more deterministic, because the main thread, after creating T1, it almost does nothing and then finish. So the main thread should finish very quickly. But T1 is a new thread that needs to be created. As I said, a thread is lighter weight than a process, but it still takes time and effort to create a thread. So in our particular case, the main thread will almost always finish faster than the child thread. So the important thing you need to remember is, if two threads are sharing certain resource, in this case the standard C out, then the thread that owns that resource, in this case the main thread, should live as long as the other thread is accessing that resource. Another thing is, you can join or detach a thread only once. So for example, now I have detached my child thread T1, and sometime later I start to miss my child and I want to join with my child again. You cannot treat your child like that. Once detached, forever detached. So this will crash your program. Fortunately, there is a way for you to test if a thread is joinable. So if I can do T1 is joinable, and if it is joinable, I call the function join. And in this particular case, I'm still not able to rejoin with my child thread, but at least my program will not crash. That's all for today. Next time we'll dive more into threading techniques. Feel free to subscribe to my channel and check out the other videos I have. Bye bye.